tanks are, but normally there's at least one on each side of the debris body. Uh, like this picture here, you can see that there's a water tank in the lower the lower water tank. You see the upper tank. There's also an option for a water tank underneath the debris body. So again, it just depends on how your truck is configured, how many water tanks and how big they are. Uh yeah, water tanks hold the water for use during the use during the operation of the truck. So again, depending on how big your water tanks are and how many, anywhere from 1,000 to 1,500 gallons they'll hold normally. But the water tanks, uh, you can get these in stainless steel, but usually they're aluminum. But the water fill, usually these are filled with a hose connected to a fire hydrant. Usually, I've heard of some guys using like a garden hose at their shop, and it takes a long time to fill these up that way. But these, using a fire hydrant, you can usually fill them 10 minutes or so, 10, 15 maybe. But that's where you connect the hose to fill it with. There's a Y strainer that you check every day. There is an air gap top of the water tank there. Those are there by law in case if something happens. The water that's in the tank will not be siphoned back into the water source. Then there's the sight gauge on the water tanks. It's just a clear tube with red balls in there that float. That'll give you a visual of how full each tank is of water. And then the tanks are all interconnected to each other. So just filling it, you just have the one fill port here. It's going to fill up all the water tanks. Same thing with the use. They all are interconnected. They go to the rotor pump and supply water to the rotor pump. So there are no separate valves to turn on each water tank, open and close each water tank. They're all interconnected. You can get an option. Usually the water fill is on the passenger side, but you can get an option to fill it on the driver's side too. That's something you may see. There are a couple options for the water level sensors. If you have the water level sensor, that option, again, just like the debris body level is in the gold. You can have this option here with the blue graph there. It'll actually give the operator a good visual of how full the water tanks in all of the water tanks, the whole water system. Not just one tank, but this is all the tanks. Basically, you'll have the sensor here on the picture on the left. It's a pressure sensor. It just measures the head pressure in the water, and it's the water in all the tanks. And again, just like the debris level, you can set at what point you want the alarm to go off. You can do the same thing here with a low water alarm. If you have this option here, you can set at what point you want the low water alarm to go off. 10%, 20%, 50% if you want. And again, when we get to the screens, I'll show you how to set those points. If you don't have that option, you're not going to have the graph in the screen on the hose reel, but there will be a float. The picture on the left, you can see there's that sensor right there. It's just a float. When that water gets to that point, you get the low water alarm. There is no set point. It's just you can't change that point. When that water gets to that point, the alarm goes off to let the operator knows he's getting low on water. He needs to finish up. Usually that's about halfway the lowest tank on the driver's side where that's located at. Filling the tanks, again, you guys technicians probably could figure this out without someone telling you. So we're just going to run through this real quick here. But if I go through this too quick, you have questions, just unmute yourself and say something. But park the truck with the hydrant centered on the passenger side of the truck. Check the white strainers, make sure they're there, make sure they're clean. Remove the cap on the hydrant, open up the valve on the hydrant before you hook up any hose to it. Flush out that hydrant. Like I said yesterday, the cleaner the water going into the rotor pump, the longer it's going to last. So before you start filling up the water tanks, before you hook up the hose, open up that hydrant, flush that water out, make sure it's clean. If that water's been sitting in those pipes for a while, they'll be brown and kind of not real pretty looking. So flush that out, make sure the water's clean, let it run until that water's good and clear. Once you get to that point, then you can close that valve, hook the hose up to the hydrant, the other end to the truck, turn on the valve, let the water tanks fill. You can turn the key on if you want, and you can, if you have the option that shows you how full the tanks are on the screen. If you have that option, you can turn the key on and watch how full it is. You also have the sight tube there on the water tank, so you can see how full it is. So you can see when it's getting to the fill point, or if you want just have the tanks be half full, you can watch that and then turn it off whenever you're ready. We do recommend draining the water tanks daily when the operator's done. Drain the water from the water tanks. If you leave water in there, you run that risk of corrosion of what you see on the pictures there. Draining the water tanks, like I said, just helps cut that down some. If you leave the water in the water tanks, you get this corrosion. Eventually, it eats all the way through the aluminum, and then you'll start getting pinholes in the water tanks, and then at that point, you have to replace the water tanks. That being said, I know a lot of places leave water on the trucks for emergencies. If you've got an emergency, you don't want to take the time to find a fire hydrant and then sit there waiting for the tanks to fill. You want to get in that truck and get going. So I understand that, but that's I just have to share that with you guys. We do recommend draining the tanks. The rotor pump. I don't know how many of you guys know how these rotor pumps work, so we're going to go through how these operate. Again, I want to go through enough where you guys understand, but if I need to go deeper, just say something. But I think I'll go through it pretty good here. This is an animation of the rotor pump. We're going to start on the oil end here. So the gold color is the oil. The water is blue. So the upper left of this, we got the oil coming in. You see the arrow coming in from the pumps. Goes into the directional valves. The directional valve is right here, laying down. There's two valves. We got two sides of the piston. So coming in from the pump, and then the other arrow going out is going back to the water tank. Okay, the oil's coming in to the directional valve. One valve is open. It pushes the oil piston one way, gets to the end of that stroke. That directional valve closes, the other one opens, the coil, turns off the coil, turns on the other coil. Now the spool shifts. Now it'll send oil to the other side. So let me do this. So let's say, okay, right now I just stopped it. So right now we got oil coming in this side, pushing this piston to the left. It gets to the end of its stroke. That sensor sees that. It turns off that directional valve, turns on the other directional valve. Now it sends oil to the other side of that piston, send it back the other way. So that's how we're getting the shifting of that rotor pump. That sensor is, Matt's going to show us that sensor. I believe I got a couple pictures of that sensor, but it's threaded in the oil end block here. It's just threaded in there. There's a magnet on the yoke that's threaded into this piston here, and the controllers will actually see exactly where that piston is along the stroke of that rotor pump. So we'll see that when we get to the screens. So now we've got that oil piston shifting back and forth. There's a rod that connects the water piston. So now we're in the water end. So the oil's shifting that back and forth. As that water piston is going back and forth, we got 4 check valves. Okay, we've got the 2 here at the bottom, I guess, might be a good description of it. That's the water going into the rotor pump. So those 2 check valves will only let the water go into that rotor pump. So those check valves are one way. So those 2 lower ones, they're a little bit bigger. They'll let the water go in, but not let the water go out. Okay, and then the discharge check valves are on top. Okay, they'll only let water go out of that the water in there. The water comes out the discharge. The one here on the left, there's a pipe that goes into the high pressure manifold. There's also the discharge on the water in block. So it'll go directly into that high pressure water block, and then it'll be diverted to whichever water circuit you're using. Normally, the rotor hose, which that arrow in the upper right is showing the water going to the rotor hose. So that's a quick explanation of the operation of that rotor pump, how that works. We do have the water in block on the right, the oil in block on the left, and the center block right there in the center. The rod that connects the oil piston and the water piston goes through that center block. And we're going to talk about that here in a minute. The last note I want to talk about with these check valves. These check valves, like I said, will normally let water go one direction. From time to time, a check valve will stick. It'll stick open, so it'll let water go both directions. Like if it's the inlet. If it sticks open, it's gonna, when that piston's going to the right, that check valve is going to be letting water in, but when that piston goes back to the left, that valve is still stuck open, it's going to let water go back out. So that one stroke, you're going to see that water pressure drop way down. And when it goes back the other way, those 2 check valves are working okay, you're going to get good pressure. So if you see that where the water pressure drops way low, pretty close to 0, you very well could have a check valve issue. Something you can do is take like a dead blow hammer and tap on the housing where those check valves are. Sometimes that'll free them up. If you find that, where it's going, the pressure dropping way off, you tap that with a hammer. Now you get good pressure both strokes. Replace that check valve. But tapping that with a hammer, it'll let you finish the job anyway. But eventually you want to replace that check valve. The last note I want to talk about with this rotor pump, this gives you a good visual of it. As this is stroking back and forth, we get pressure. We've got like we're cleaning a line, we've got a nozzle on the end. We can build pressure with that resistance of the nozzle. Okay, as that piston is traveling, we get good pressure. It gets to the end of that stroke, that physically has to stop and go back the other way. Just that little bit of a stop gives us a drop of pressure, and then as it gets going back up, that pressure gets built back up. That action is what we call our jackhammer effect. And we're going to talk about that a little bit later here, but just gives you the visual of what that is with this animation here. All right, the water flow to that rotor pump. Okay, water is coming in from all the water tanks. There is an inlet valve there. If you're used to a plus or classic, there's a gate valve here where this elbow is in the upper right. That gate valve is gone now. We have this valve here. This is air controlled. There's a switch on the control panel. I'll show you that here in a couple minutes. But this valve here has to be open. Again, we got water coming in from the water tanks. This valve is open. Now we have water supply to that rotor pump. If you got that valve closed, now we don't have water supplied to that rotor pump, and it's not going to pump any water, obviously. We got the heat exchangers. The first one is the hydraulic fluid heat exchanger. So this is what we use to keep the hydraulic fluid from overheating. Then if you have a second one, that is an option. That's an engine coolant heat exchanger. A quick note on the hydraulic fluid heat exchanger: if you've got water and oil mixing, that is the only place in this water system that the water and oil are close to each other. Okay, so if you've got water and oil mixing, this is where I'd be going to. There's one other thing that's going to come up here in a minute, but for the most part, if you've got water and oil mixing, I'd be looking at that heat exchanger. But like I said, if you have the optional engine coolant heat exchanger, that'll be your second one. The water flow goes through from there goes to the water strainer that you check every day, and then goes into the rotor pump. You got the inlet check valves, and then you got the discharge check valves mounted there. And looking at the rotor pump, when it's mounted on the truck, the oil side's on the left, the water side's on the right. You can tell the water side, the plumbing there, that's the water inlet. So the big hoses there, it's a big giveaway that that's the water side of the rotor pump. But the inlet check valves are mounted inside those. So if you want to get to those, you got the 4 bolts on each one. So not real complicated to get to those check valves. And then the discharge check valves are mounted on top here. Again, that's going to let the water out into the high pressure manifold there on the right. There's the remote drains. Most of these, I can't remember the last time I've seen a rotor pump without the remote drains. I believe those are an option. If you don't have these, there's going to be drain plug, one on the center block and one on the oil end block. You'll have to take those out to drain the water from the rotor pump. But like I said, most of them have these drains. Open those up to drain the water from the rotor pump. There are 2 smaller drains, one on each side. Those are for the heat exchangers. If you only have the one, you're only going to have one of the smaller ones. If you have both heat exchangers, you'll have 2 of the smaller drains there. A quick note on the cylinders. I don't know how many of you guys rebuild your rotor pumps. I know, like I said yesterday, there's a good couple of dealers here I know. So I'm pretty sure you guys rebuild the rotor pumps there, or someone does. Ordering the new cylinders, they are color coded. Okay, when the rotor pump leaves here, they're painted so you don't see the color. But if you were to order a new cylinder, they're not painted, but they're going to have this paint stripe on it. Okay, the oil and the water cylinders, they look the same, are very similar. The sizes are the same because this is a 1-to-1 pump. So whatever the oil's doing, the water's doing. So the sizes look different. So we do mark these. The previous oil barrels were the oil was blue, the water had a black paint stripe. But recently we changed suppliers. Just the whole trying to get parts here. So right now, the oil is painted red. You can see in that upper picture. The water is green. They eventually might go back to the previous colors. Again, just to throw out some information for you guys. If your rotor pump's painted, they are marked O and W for oil and water. They're stamped with those letters, so you know which barrel is which. Because as you're rebuilding these, you do not want to mix these. The water is harder harder material than the oil, so you don't want to mix up these two. The valves, again, if you're used to the plus, you don't have these air switches here on the water control panel. The valves are different now on the 2100i. We're going to go through these switches, what they are, real quick here. But the one on the left is the rudder pump inlet valve. That's the valve I just talked about. So that switch has to be up. That opens up this valve, so now the water supply will actually go to the rudder pump and you can pump water. Okay. So don't forget about that switch if you're trying to run water through this rudder pump. If that switch is down, this valve should be closed. You're not getting water supply to that rudder pump, and it's not going to pump any water. All right, that switch on the right, it controls this valve here, this blue valve that's mounted on the rudder pump. Okay, if you're used to a classic or a plus, you've got the big handle valve on the hose reel right next to the control panels. That valve is gone on the 2100i. This valve here is doing that same job. Okay, so with that switch down, this valve is closed, and now you can open up another valve on that water control panel and divert the water to someplace else. Flip it up, that valve is open. Now the water is going to be diverted to the hose reel. Let me blow this up real quick here, just so you can see this. Right there, that blue block, that's that valve. On top of that valve, you see that red, looks like a knob. It's got a white stripe on it. That gives you a visual if that's open or closed. All right, so just so you guys can see, so you know what you're looking for here. This switch is a 3-position switch. Okay, the rudder pump inlet valve, the one on the left, is a 2-position, open or closed. That's it. There's a hose reel main water valve, that switch. Again, they're sending air to these switches, are the valves. So it's a 3-position switch. Up is open, down is closed. Then there's a center position. That center position just holds it in that valve in whatever position it's at. So if you have it flipped up, that valve is open. You put it in the center position, it's going to stay there. If you want it closed, flip it all the way down. That valve is closed. Now you can put that switch in the center position if you want. Don't have to. It's going to hold that there. Why is that 3-position? Why we use that 3-position? A few reasons, but if we want that valve partially open, let's say we start with this valve if it's all the way open, but we want to partially close it, put that switch in the center position. Now just tap that to the down and let it go and let it center itself in the center position. And you can watch tapping that switch to the down position. You can see that indicator move to give you a good visual, partially open, partially closed. Matt, well, actually we don't have our truck right now, but at some point Matt will show us this on the truck so you get a good visual of what I'm talking about here. Speaking of that, Matt, our truck is done. We just got the email, but right when we started here. But anyway, the one of the reasons why you might want that partially open, partially closed, if you have the recirc option on your truck, you can have the water circulating in the water systems on this truck as you're driving down the road. A lot of guys will just circulate the water through the rudder hose. It goes back to the tank, goes through the tank, goes back to the rudder pump. Rudder pumps water, goes back to the rudder hose, back to the tank. But you can, like the handgun, you can recirc water through that also. So if you want to recirc water through multiple circuits, you have to have this valve partially closed. All right. The water valves on that control panel, depending on what your truck is configured with, what options it has. There's a body washout on the left. A lot of trucks do have that. If you have a fan unit, you can have the fan washout. There's a optional high pressure hose. There's a high pressure coupling option. Usually at the front and rear bumpers where those couplings are, and then there's the high pressure hose reel. Every truck's going to have that. And then the other thing on that water control panel is a possible air purge option. If you're in an area where there's going to be freezing weather, you might have someone that opted to get this option on their truck. And we'll talk about the air purge option. That's to winterize the truck. If the truck is going to be in cold weather, you don't want things freezing. You don't want the water freezing. This system uses chassis air to push the water out of all the water systems on the truck. But we'll talk about that when we get to the winterization later, probably this afternoon. The heat exchangers, like I said, we're going to have one. You could have the second one as an option. The second one is for the engine coolant. The one with this green valve, that valve opens up when the engine coolant gets to 96 degrees. Now we can send engine coolant through there and help keep that engine cool. All right, there are seals throughout this whole rotor pump actually, but the center block, there's some seals here I want to talk about. The center block, like I said, that piston or that connecting rod goes through that center block. So you're going to have a seal on the oil side and a seal on the water side. On the bottom, this is a bottom view of that rotor pump. There is a weep hole. Okay, if something is dripping out of that weep hole, one of those seals has failed. Okay, so if you've got water dripping from that, the water seals failed. If you got hydraulic fluid dripping from there, you've got the oil side seal has failed. You're going to have to rebuild that rotor pump, tear it down, and replace those seals. All right, this picture here on the left, we have a cutaway of the rotor pump down with Matt down in the show bay. The seals, I've called out the seals here. Again, it's the cutaway, so we've cut got the seals cut away there. Normally, it should be complete there. But you can see there's an O-ring on the pressure side on the oil and water seal. So if one of those seals fail, that fluid's going to come in here in the middle. Right there, there where my red dot is where that's going to be diverted. It's going to go down and out that weep hole. All right, the picture on the right just calls out, just for giggles, let's blow this up. So there's that weep hole. This is where that seal sits at. Okay, if that seal fails, that fluid gets packed back in there, fills up this cavity, and goes out that weep hole, comes out the bottom. Okay, there's a closer view of the seals. That's where the water, that fluid's diverted down that hole there. Oh, like I said, if you've got water or oil dripping there, you're going to have to replace one of those seals. You're tearing that rotor pump all the way down and replacing those seals. Okay, if you have something dripping, replace the seals. Do not plug that weep hole. Some guys are tempted to do that. If you plug that weep hole, what you've done now is cause yourself a lot more work. Let's say you got water dripping from there. I don't want water dripping. I'm going to plug that up. Problem's fixed. No, it's not. That water seal has failed. Okay, that cavity's filling up with water. There's pressure in that water. That water gets pressure in there. It's going to push water into the oil side. Now you got oil and water mixing. Eventually, your oil tank's going to fill up. You're going to get water or oil coming out. By that point, it's going to look like looks like you're going to tell just looking at it, you're going to tell that the oil's been compromised with water. But now you're going to have to flush the whole oil system out, the whole everything on that truck. So, like I said, plugging that, now you've caused yourself more work. If you've got that dripping with oil, okay, no, I don't want that dripping, I'm going to plug it. Yeah, okay, you stop that, but now you're just pushing oil into the water system. Now you're losing oil. Eventually, you get low on oil. Are you going to destroy something because you're too low on oil? Quite possibly. So don't plug that. If you got something dripping, fix that seal. Earlier, I told you if you got water and oil mixing, look at the that heat exchanger. Before you tear that apart, just give a quick look. Make sure someone hasn't plugged that hole. Someone plugged that hole. That's where your mix could be coming from. Okay, so just a quick note on that. A white strainer, we've talked about that. Check those every day. Again, the cleaner the water going into that rotor pump, the longer it's going to last. If you've got dirty water going in, you're going to destroy those seals, the cylinders, the pistons. Now you're rebuilding that rotor pump a lot sooner. This is that linear sensor I talked about. That's what that looks like. It's screwed into the oil end block. There is here, this picture here. You can see here on the right, there's the magnet. This yoke here is threaded into the rod there in the oil piston. As that rotor strokes back and forth, basically this magnet is going back and forth the length of this sensor. This sensor, like I said, is threaded into the block. It's stationary; it doesn't move. But this magnet goes back and forth along this sensor. Now the controller can see exactly where this is at along the length of this sensor. There inside this sensor, it looks like a big circuit board. So it knows where that magnet is, so it knows exactly where it's at along the stroke of that rotor pump. Okay, there is a blocking valve. A quick story on the blocking valve here, what this is, where it came from, why it's there. This blocking valve, if you have a 2100 plus and you're just using vacuum, you're vacuuming up something, you're not using water, you're not pumping water for anything, you're just vacuuming up something. I actually had a truck out in Nevada, I believe it was, where they're at a power plant and they had a lot of sediment in their big cooling lake. So they're trying to vacuum up some of the piles of sediment underneath the water. They're at the edge of the water and they're just vacuuming, so they weren't using the rotor pump for anything. This was on a plus. So again, if you're just vacuuming, not using water, the hydraulics are going to overheat on those trucks in an hour. Okay. If you're not using water, the water's not going through that heat exchanger, not cooling off the oil. But the main thing is, since that rotor pump is not being used, that spool in the directional valve is just staying there in the center. It's not a complete seal, so there's bypass in that spool and that directional valve. So when you go from high pressure to low pressure, there's heat builds up there. So again, you're not using that rotor pump. Heat builds up in the hydraulics. You're not cooling that hydraulics fluid. That it's going to overheat in an hour. Okay, the ambient temperature might swing it a little bit. It might be 55 minutes, hour 10, but right there about an hour, hydraulics are going to overheat. What they've done is come up with this blocking valve. So when you're not using the rotor pump, this blocks off all hydraulic fluid to the directional valve. So now we don't get that bypass through that spool anymore. So we don't get that heat buildup. When you turn on that rotor pump, that blocking valve opens, lets hydraulic flow to that spool valve. We're using the rotor pump. we're not causing that heat like we were if we weren't using that rudder pump. So try to make that a quick story, what that is, why it's there, where it came from. You could see a couple different visuals of the directional valves. The one on the left that looks like the directional valve is standing upright. That's a little bit bigger. That's the D10. Those are on 100 gallon per minute and higher units. The DO8 looks like it's laying down. Still operates the same way, but that's the 80 gallon systems. Some of them are 60 gallon, 70 gallon. So 80 gallon less is the DO8. 100 gallon more is the D10 on the left. So you could have your directional valve can just look a little different again. Just so you guys know what to expect there. All right, this high pressure manifold. Some things on this that I want to call out. On the screen, we display the water pressure. That's where that water pressure sensor is at. That's actually in that manifold. That's the location of that sensor. The hoses, this one out the front, it's going to the hose reel. You could have, depending on the options on your truck, which hoses where they go to. A couple options there. If you have the air purge that we talked about, that we use to winterize the truck, this gold color, that's a check valve. This is air coming into the system. So we put a check valve in there so we don't have water going into the chassis air system. There's accumulator. I want to point out here, remember this because I'm going to mention this when we talk about winterization. We'll talk about the accumulator here in a few minutes, but I want you guys to see this line here goes straight down to this high pressure manifold. So when you drain this, there's a drain plug here. It's going to drain all the water out of this, all these lines here. There's this other line here goes to the buried relief. That is the water pressure relief. All right, that's what we're going to talk about next. That's the buried relief. That's what that looks like. That's where it's located at. We just saw the other end of this hose. Okay, like I said, this is the water, the relief for the waters, the router hose. Okay. Adjusting this, these are adjusted to, again, if we're talking at 2,500 PSI, normally this is going to be set at 2,500. Okay. With that said, if you're doing any kind of adjustments on your truck, okay, I've got some numbers. I usually go with a 2,500 PSI system. No matter what your truck is configured with, get the build ticket, call your dealer if you need to, call Vactor service. Make sure you get the right values for things that should be set for your truck. Okay, so if you've got a 3,000 PSI system, you're not going to be setting this buried relief at 2,500. So, but like I said, I use numbers that I feel most of these trucks are, but know your truck. Don't just go by these numbers. Get the schematics, the build ticket. Make sure you have the right information for your truck. But with that said, this is the buried relief is normally set at 2,500. The 2,500 system. There is a a hydraulic fluid relief set. Normally those are 3,500. That hydraulic relief is oh crap, something terribly's gone wrong. That's the highest point and the system there. Then there's the compensators. The compensators on the pumps, those are usually set at 3,100 for a 2,500 system, PSI system. Those should be, the compensators is the first control on the hydraulic side. Okay, like I said, the relief is oh crap, something went terribly wrong with the compensators, and then the buried relief is the relief for the water system there. Adjusting these, okay, I'm going to walk through this real quick here. because I don't know how much you guys are gonna remember this when you need to get to this. It might be a year from now or whatever. But adjusting this, there's the adjustment, that bolt there. So loosen the lock nut, turn in that bolt a few turns. So now you've set this higher than the 3500, or it should be. Okay. There's a cap on top. Remove that cap. Now you can visually look inside. If you want to, you'll see water coming out when we get this set also. So remove the cap, turn on the rotor pump. So you've got the engine running. You've got it shifted to jet mode. So turn on the rotor pump. Make sure you have a sufficient nozzle on the end of the rotor hose, something that you can get your system pressure and flow. Again, on a 2500 psi, 80 gallon per minute, make sure your nozzle can do that. All right, increase the engine RPM to max using the potentiometer multi-flow, and then you can watch the pressure on your display there on the hose reel. Using the multi-flow, just start low, turn that till you get 2600 psi. Okay, don't go any further. Just go to that 2600 psi. Then start slowly opening up this adjustment here. Okay, slowly open the adjustment valve until water starts to come out the port with the cap. So the water starts coming out here. That tells you we're starting to open at 2600 psi. Okay, start closing the adjustment until just the minimum amount of water is bypassing. So now you can look down in that where that cap was at. You can look down in there and see that there's just a little bit of water coming out. Okay. Now using the multi-flow potentiometer, lower the water pressure to 2500 psi. Double check that there is no water bypassing the valve, and then tighten up that lock nut. Let's see, reinstall that cap. Lower the engine RPM, turn off the rotor pump, take the truck out and run it if you can't do it here, but operate the water systems, make sure you can get the water flow and pressure that the truck is rated for. So a quick run through of how to adjust these, the beared relief. All right, next thing I want to talk about here is the accumulator. Okay, the accumulator is a water system shock absorber. Okay, remember when I was talking about the operation of the rotor pump? As that thing's stroking back and forth, it gets to the end of the stroke, the pressure drops down, it starts going back the other direction, that pressure is going to go back up. You're actually going to see that on your gauge. You're going to see that the hose reel is going to vibrate when that happens. You'll see if you can watch the nozzle, and I have a couple of videos showing this, the nozzle will actually jump, showing that jackhammer effect. This accumulator, you can open up this valve. Now we get this shock absorber, and it takes down that, it smooths out that spike. So it's a lot smoother operation. All right, how does that work? Okay, there's an air bladder. It's filled with, let's go back to the previous page. It's charged with dry nitrogen gas. Okay, 1000 psi. When it leaves here, it's got 1000 psi charge in there. So this bladder is full of nitrogen, 1000 psi. Okay, as we're using the water system, if that valve is open, it's going to force water into this cavity here. Obviously, this is cut away what that accumulator looks like inside. That water fills here as that rotor pump is working. When that water pressure gets above 1000 psi, it's going to collapse that bladder. Okay, that water, that rotor pump ends its stroke. Reaches the end of the stroke. That pressure drops. When that pressure drops, that bladder pushes that water back out. So that's the shock absorber effect. So instead of dropping 1,000 psi, you're still going to see a drop a couple hundred psi, maybe something like that. So it just smooths that out. That rotor pump or that rotor hose, the hose reel vibrating with the, the that jackhammer effect. That hose reel will vibrate. This accumulator with it turned on will smooth that out. You'll see that. All right, so this process will limit the water pressure between the drops between the strokes of the rotor pump. So here is just a couple of videos. This is a video. Matt and I shot this out back. We've got this clear pipe on the hose. This is with that accumulator on. It's pretty smooth. You don't see that jumping around. It just goes smoothly down that pipe. Okay. So this next one is the accumulator off. It's not a real good visual, but it gives you some kind of clue what's going on here. Right there is a jump. If it was up against blockage, it'd be more pronounced. But just that little jump there is that jackhammer effect. Okay. Sometimes you want that jackhammer effect. If you're up against blockage, it'll help knock that blockage apart. If you're on a long run, you're trying to get 500 feet out, you might need that little extra jackhammer effect to get out a little bit further. Or if you're going up a hill, that jackhammer effect will help that also. All right. Like I said, I don't know who, if anyone other than the dealers rebuild your rotor pumps. Matt's going to walk us through that down here, coming up here in just a minute. But there's tools. These are just a picture of all the special tools that will make that job a lot easier. So if you're thinking about rebuilding your own rotor pumps, I'd suggest getting these tools. These are in the PDF that I gave you guys the link for, but it gives you all the part numbers and what each of those tools are for. So just again, if you're wanting to rebuild these rotor pumps, these tools will make it a lot easier for you. If you don't have these special tools, it's going to be a lot more work. So with that, I'm going to hand it off to Matt, and he's going to walk us through this rotor pump down there at the show bay. So let's see if he's with us anyway. There he is.
Good morning, everybody. I would love to show you guys stuff on the truck, but they took the truck back to do a little bit of rework. There was a couple things that we were not exactly okay with, and they're going to fix them. So that truck is going to be better than what it was when it was sitting here yesterday. So I don't have a truck today, so at least for now. So we'll get back to that when we need to. There was just a few things as far as plumbing goes, and then the valve for the on-off for the rotor hose, things like that I was going to show you guys. But it's okay. We can come back to that stuff later. It's not the last time you guys are here, and it's not the last time I'm going to be here. So we'll go back to that stuff later. This is that cutaway that Jerry was showing you guys. So as you can see, the barrels have been cut open, so we can see what's going on here. You can see the check valves inside the 90 and then inside the T. So this is the check valve. That's what it's doing. As the pump goes away from the check valve, it pulls the water in, it pulls the check valve in. When the piston starts coming back, it closes this check valve and opens the high pressure check valve on this side. And then it leaves the pump. The two high pressure blocks are connected via a hose. Most of the plumbing usually comes off the high pressure side manifold on that over there because there's a lot more ports. Plus it connects the two together. So that is the gist of what's going on. Couple things to point out. As the I came out, they made some grand improvements on some of these manifolds. They're now coating them, and they're using a coated bolt. So anybody who's ever tried to take one of these off knows that these bolts love to seize into these blocks. And you get to cut them and get them out and pound them and weld them, get them out of the center block or the end block. You can see the seals. If anybody has any hydraulic experience, the seal looks very, very similar. It's got a scraper seal on it with an O-ring that goes towards the pressure. You're going to hear me say that 105 different times. You can see that this is the piston and ring lands, because I don't really know what else to call them. So there's where your seal and the piston, that's how it operates. So it'll pressurize one direction, and then when it comes back, it pressurizes the other. So you can see, depending on which direction the piston is going, it's either pumping out one side or sucking in on the other. So that's how that goes. It's no matter which cycle we're talking, it's not only is it pulling water in, but it's pushing water out. It's connected with the shaft, so the hydraulics are doing the work, and then the water is then being moved around. So that's how that really works. Right here in the middle is the center seal. So the O-ring towards the pressure, it keeps pressure on one side or the other. Once the seal has been compromised for whatever reason or another, that's when you're going to get that leak down through the center, your center block down here, and it's going to leak out the weep hole at the bottom. Anybody who comes from an automotive world where you have water pumps, I'm sure it's not just limited to that, but that's usually where everybody's experience usually comes in. Water pumps have a weep hole on them. I'm sure that everybody has seen something like that. So there's your witness that one of those seals is leaking. So you got water coming out the bottom, that's what it is. You got oil coming out the bottom, that's what it is. And we're going to talk about the rebuilding over there. I have a heat exchanger right here. And if you guys have never been inside one of these, it's just a bunch of copper tubes. This is an old version, but it's still the same thing, a bunch of copper tubes. So oil is going through one end and then going around all these coils and coming back out the other side. And then the water is flowing through your inlet water to your pump. So the water going through there, and it's just a water to oil cooler is what it is. And if you have two of them, it's a water to engine cooler. So that's how that works. If you guys, because we're mechanics, if you guys are doing the maintenance on this truck and you close your shutoff valves and forget to open them and run your hydraulic oil pumps, you're going to collapse the small copper tubes in there, and then you will create a oil water mixture that is just so much fun to get out. So don't do that. That's also a spot where if you leave water in here and you don't drain it, it cracks the tubes because it freezes, and then now your oil will mix with your water. So either you're going to run out of oil or you're going to get a whole bunch of watery oil in your system. So either way, that is a no good scenario. All right, you can see yeah, that's the oil manifold. Directional valves, that's it on this side. Most of them are laying flat. It's only the 100+ systems or the D10 that are stood up straight. So there's the gist, all right, on the router pump. I'm going to take you guys over here. I'm going to put you guys up in the sky so you can kind of see this a little bit better, so I can move you guys around. So you're not going to watch the ceiling. I'm going to do my best to try to kind of take this thing apart. Not everybody's going to rebuild them, but it is kind of nice to see a pump come apart. So here we go. Now that I'm touching tools, I got to put my safety goggles on. All right, so there's a ton to this. Obviously, this pump has been deemed it needs to be rebuilt. One reason or another. So the next section, when we start talking nozzles, then we're going to talk about performance. But right now, let's just assume that we had a leak out of our weep hole, and the seals inside here are the reason. Or as we'll learn here is when we move on to the nozzles, the performance. So maybe our seals on the piston are worn, or yeah, those are the main reasons. We're going to talk about what can cause the seals to wear out as we're taking it apart. So we'll move through the diagnosis of a broader pump that is worn out as we're moving through this, and then we'll finish it off in the next section as well. So those questions just kind of hold on to. I'm really just want to try to show you guys a pump coming apart using the tools, using these tables, and then we always get the question of how do I know whether I should rebuild it or should I buy a remand? Should I take it to a dealer and let them rebuild it? Should I just buy a rebuilt one and put it on? Should I buy a brand new one? It all comes down to, I'm going to say, your checkbook. And that's where I can kind of leave it. You guys get to make that call based on the amount of tools. We're going to call them special tools because this is the only place you'll probably ever use any of this stuff. Then you have to have the experience to be able to take this apart, put it back together, and feel confident that everything's going to work. I know it's super simple, but there's just a ton of stuff going on here. And if you're not set up for it, this can really take a long time, and you'll have a lot of hours into this. And then if you only have one truck, investing into all this stuff is you might use it once in the life of that truck. So that's a lot of an investment for a one time, whereas you could just take it to a dealer and get it done, or buy one rebuilt and send them your core or something like that. So yeah, the decision I can't make for you as to whether or not you should rebuild it or have somebody else do it. So like Jerry and I always say, the easiest way to get something done is to have somebody else do it. So but I'm not the one writing the check either. So there we go. All right. Enough said. So we have to take our water supply off first. Well, how about we get our pump off the truck? And there's only one way we're going to do that, and that's to disconnect how it's mounted to the truck, which is usually to the bottom of the center block. And then you have your hydraulic on your hydraulic end, and then you have all of your water lines between your center block and your high pressure manifold. And then you have your water supply with your Y strainer usually on this end. And we're going to leave that one alone because trucks get configured all sorts of different ways. The biggest thing I can tell you guys is every one of you probably has a camera in your pocket. Take a couple of pictures just so that you can put everything back where they are. I know that I am absolutely guilty of this, and I take things apart and then don't really take a mental picture even. And then when I'm putting it back together, I was like, well, I guess I'm going to make it better than they originally sent it to me, and I put things where I want them. So yeah, I guess that's the curse, right? Okay, pumps off the truck. I don't know of any way you can do this on the truck. If you want to try it, go right ahead, but I don't know if it's a great idea, especially trying to get us apart. So we're taking it off the truck. It's off the truck, on the bench. Supplies are off. So you have a T on one side and and then it comes out. This is why tapping on that elbow or the T will actually help you sometimes, because eventually there's enough corrosion in your water that the thing likes to open. These things are cycle torture tested, we'll call it, for lack of a better term, where they have a machine that just opens. 1-inch drive, 3/4 drive. So you need a big boy impact, and then you might be able to rip the nuts off. If you're lucky, the truss rods will start spinning during this process. If the nuts come off, all 8 nuts come off, yeah, you're going to have a fun day, because now you're going to have to try to get this truss rod out of your blocks, your end blocks, and that's usually because they're rusted into the hole. Lots of suggestions on how to get those out, but basically you're going to get very physical with those truss rods. You may even have to cut them. They just don't damage it. Don't mushroom the end of the thread, because if you have to cut it and now you have a cut end and a mushroomed end, now you're, which way do I go to get it through this hole that's already full of rust and nasty? So there you go. There's your truss rod heads up, okay? Rule number 1, truss rods are going to fight you. So we're going to take our truss rod off with our big old nasty impact. We're going to drop our nut on the ground because that's what we do. We don't need it anyways. The next thing about the truss rods that I want to let you guys know, we've had this question before. Is there a lifespan of the truss rod? Can you torque it too many times? Is that a replacement item? As long as the threads are still good, you can reuse it as many times as you want. That's like a 1-inch shaft with some really crazy steel. It is not going to stretch to a yield where it can't be reused. So this is a significant structural item. So you can reuse that as long as the threads are in good condition. And then the last thing I want to point out before I set the truss rod on the ground is the fact that I have, like 2.5 inches of thread here, and I have close to 4 inches of thread at that end. The longer threaded end always goes to the oil side, and that's for us. That's how we torque them here, because we have a machine that does it consistently every single time, and it torques it to 1,400 foot-pounds from us. When we retorque it over there on that bench, you're going to hear a different number, 1,200 foot-pounds. Okay, so there was your heads up on the truss rods. That's all I can really say about those until somebody asks me something, or maybe something else will pop into my head. But that's the battle with a truss rod. All right, so you saw me take this plate off. Actually, I had to, because otherwise it was going to go where the nut went on the floor. You have plates. You can have a plate that has ears on it, like this one, or you can just have a regular old shim plate like this. Reason that these things are on here, and this is a very important point to make sure that everybody understands, is the fact that the ear of this water block is thinner than the ear of the oil end block. Years and years and years ago, so back in the 1900s, they discovered that they had to thicken up this ear, otherwise it would actually snap off. So if you notice, you put either one of these on the end here, it becomes the same thickness as the oil end. So it's a washer, technically it's a shim. Technically put this thing back on this pump or you're going to have problems. How's that? All right. That's what those washers are for. The reason that some of them have the ears is sometimes we mount other things off of the rotor pump, tie-off points for hydraulics, whatever, additional components, all sorts of things could get attached. So that's why these are on there. Once again, that's where that camera and that picture comes in handy. You make sure you put them on in the right orientation, the right side of the pump, whatever. So, okay, that's why these are here. That's what they're for. Make sure they go back on the truck. The same way they came off. They always go back on. All right.
Are those reusable, or are they replacement?
Yeah, as long as they're in good shape, just like any other washer would be. If it's in good shape, put it back on. A lot of times they get, like really rusted or whatever, but if they're still would you reuse it shape? They don't get damaged, they just rust. I don't know that I've ever actually replaced them for any reason. I think I may have always reused them. The only time I could say that we replaced them, and I can't even actually remember a specific time, was if they were just that nasty that after they got, we would blast them because we wanted to paint it to make it look pretty. If you blasted it and it was just all pitted and just nasty looking, we'd replace them, but we're only this far from the factory, and sometimes maybe they didn't get charged. So, but no, I wouldn't, you would not normally replace them. Nope. Nope. All right. So just make sure they go back on the water end. Okay. High pressure blocks. I kind of alluded to it before with the coating that is on there. I'm going to walk this over to the camera in a second. So a lot of times I would almost say 90% of the time, if not even a little bit more than that, those bolts did not want to come out. So you just get your cutoff wheel down in here and you just zip these bolts off. Then you can get your check valve out of the way, and then you'd end up welding nuts onto what was left of the bolt and weld a nut on there, and then you'd rip the bolt out. The bolt's actually stuck in the high pressure manifold, both sides. So you can see all the corrosion and rust inside there. The bolts did the exact same thing. I'll guarantee you the bolts were cut and then pounded out of this. So once they're cut, and then you got that little bit of a bolt sticking out, you lay it upside down and you whack it with a hammer, and the bolts come flying out, and then the bolts are done. But if you can see the lip that's missing for that O-ring, see how it's all decayed and rusted and corroded? This block got replaced because of that. This is what you're going to consistently find on all the O-rings on this pump right here. So once the O-ring land corrodes, rusts, decays, it does not any longer hold that O-ring in there. And if you're putting a warranty on that, you're not putting something like this back on. So if it's your truck, take your chance. Go ahead. These are on the outside. What's the worst that could happen? It's going to leak? Probably. Okay. So that's why these would get replaced for the cost of them. They're pretty cheap. In comparison to some of the other components. Here's your high pressure check valve. So it's just a smaller version. There's a much higher spring pressure here. So this one gets pushed open. When the piston moves towards it, it gets pushed open, and then the spring pressure closes, and then it keeps the water from the high pressure side from the other side of the pump, whichever, and then it just closes and doesn't allow water back into the pump on the other side. So pretty simple. These are not usually the ones that get stuck. That spring tension on there is pretty significant compared to the other side. Okay. All right. So miraculously, we got the truss rods out. Everything worked out well. They came flying out of here. We had a successful day. This O-ring land is in good condition, and the only other one we'd be concerned about is going to be on the inlet side over here. Is that in good condition? And then we flip this boy around, and that came off really easy, didn't it? Yeah, that's not going to happen. The water barrel goes on this lip. I know it's really hard to see, and I am not picking this thing up so you guys can see it. The water end block actually goes into the barrel, and there is a 1/4 inch that holds on. You would not believe. So there's that 1/4 inch. These two love to gather together forever. And then there's an O-ring that seals the end of the barrel to the block. This is another spot that can actually just deteriorate, and there's no longer a ledge. And if you guys were here, you'd be able to see it a lot better. And like I said, me grabbing the camera is the only other way. But just think about it. If it goes into the barrel and it starts corroding away, it no longer locates in the barrel. The edge is gonna disappear and corrode. I think you guys can understand what I'm saying. So it no longer holds onto the barrel. That's the other way that this water block can fail. A note on the O-ring lands. Years and years ago, so once upon a time, we actually used to machine them here in the machine shop, which is on the other side of this wall. I know you guys don't know that unless you've been here, and I'm pointing like you do, right? Silly, old habit. We used to machine these so that they could actually put in an insert, and they'd put a new O-ring groove land. They'd put that into the center block and the end blocks. We no longer do that here. If you guys have a machine shop that you're real close with, or is also part of your business or something like that, there's a good one in town, whatever. They may be able to machine these for you and save these end blocks or center blocks. I don't know. So once again, is it worth it? So that question will come up over and over and over and over and over again. All right. Since I got to switch back and forth, I'm going to just kind of have you guys use your imaginations, okay? So I've pounded off my water block, my water being on here. What water would have been in here is now on the table. There shouldn't be a whole lot because the drains in either block. Now we need to remove our water barrel from our piston. I don't know of any other way to do this. I guess I was never forced to try to figure one out. We always had this special tool, so I'm going to pick this thing up and, show you guys. I know I needed to adjust it a little bit. I slid it and I slid my strap. Now I gotta find the happy spot again. All right. This I can bring over to you because it's not 70 pounds and I don't have to pick it up. All right. And that's the end of the crank. All right. So this one has Allen bolts. Basically, it's a 3/8 bolt into the end. It just clamps onto the barrel. Okay. This clamps onto the barrel, grabs onto the lip of it, and then it has this big old Acme screw on here with a handle. And then if we turn our light on the inside here, you guys can see that there's a pusher plate. That pusher plate in there pushes up against the end, the piston, the end of the piston, the end of the center shaft, and then pulls the barrel off of the piston. Okay, that's how that puller works. That's why it's called that. If you guys can see, trying to, this is gonna be maybe it's better without it. Not really. Trying to hold it. There, that's pretty good right there. You guys see this right here? And then right inside there, it's actually rust. What happened inside here is the wall of the piston rusted and then it flaked off. When it flaked off, now that is actually destroying the piston, the seals on the piston. It'll start wearing on the piston as well. So if this barrel is not perfectly smooth, perfectly clean, think of a cylinder of any sort. Anytime you have a cylinder, a piston in a cylinder, if the walls aren't in perfect condition, you're just going to destroy the rings or the seals, and then that has to be replaced. So that's why this barrel was replaced. This is actually the water barrel, not that one. That one's just set there because of this whole scenario I'm trying to show you guys. So before anybody gets all hot and bothered about that. Okay, so there's your puller inside here. That's why this was replaced. That's what you're going to find wrong with the barrel. Most likely only on the water side. Not going to say that the oil side never fails, but I don't know that I don't know of an oil barrel ever being replaced. Sure as heck not from rusting. I can tell you that part. If an oil barrel rusts, then there's obviously no oil in it or a whole lot of water. All right. Shouldn't need that again. All right. I took my tool back off, so now I can take my barrel off, right? We're all good. I'm going to stand it up on its end. All right. If we were here in class, I would mess with you guys as you're taking this apart. I do my very best to distract you, to try to switch the barrels on you. When you mark them, I'll try to erase your mark, and I'll try to mark it the other one. And then I'm going to ask before you can put this thing back together, which barrel is which. Jerry gave us a little hint. He said that the water barrel is harder than the oil barrel. Okay, that's cool. What do you want me to do? Tap on it, touch it, bite it? Like, how do I know that it's harder? Everybody's watched Forged in Fire, right? I think that's probably like one of those shows that everybody's seen. They always do that file test when it's hardened. The file will just slide across that water barrel. It's harder. There's more chrome in there. It just slides across it. You do that to the oil barrel, it digs in real easy. This barrel is just made of softer metal, softer steel. So the file will bang into it. If you're musically inclined, you'll understand this. Most of us can hear it, but it doesn't mean anything to us. I say that because that's me. You can take a file or another piece of metal and you can ring it, just whack it, and you'll hear a higher pitch out of the harder steel. So you can identify your harder steel. If you have a brand new pump or you got a new barrel and you're trying to figure out which color is which, forget about the colors. Forget about it, right? There is going to be a stamp on the barrel. It's going to have a W for water or an O for oil. It'll be stamped into it. So you don't have to worry about banging on it, smelling it, tasting it, which one's harder. It's marked on the barrel. The new barrel will come marked to you guys. That's just for the old ones. Can't take a picture of a black barrel and put a black barrel in the wrong spot. Okay, we're good there. We're going to move on to the piston now. All right, we're going to want to take, we've now that we can see the piston, we're going to evaluate, are these seals any good? Is the piston any good? I don't know. And then the last and final thing we need to do is get this shaft out of here so we can get into the center block, and then our pump would be completely opened up. And this will be the last. We could basically stop right here as far as the evaluation goes. If we're going to finish the rebuild, then we need to remove the center shaft, and we'll get to the oil end in a minute. So we're looking at the piston. It's just like any other piston. Are those ring grooves or seal grooves? Are the lands in good shape? Did the piston get destroyed? Has the piston been chewing on itself? This one has not. There's a couple scratches on there, but most likely that's because it's been assembled and disassembled 350 times. I don't know, a lot. I can almost push the barrel on and off. So this one is not a good example as far as that goes. These pistons, when they are not when the seals are not performing well, they literally are flat. When you rub your finger across them, you can't catch the edge, the scraper part of that seal. And that's usually why the pump is not performing, is the seal has failed. Most of the time, that's the reason. So if the seals are completely worn out, I can't tell you how many of these I've taken apart. The piston has been destroyed and the seal is remnants of a seal. So where would that rubber go? If it's coming out of your pump, where does it go next? Small circuits, nozzles. Anybody ever had your operator come to you with a nozzle and be like, what is this black stuff in there? And they show you and it's just got little pieces of shrapnel in it. That's your seal. Your seal is deteriorating. It's coming apart. That's what's wrong with it. There's only one way to this bad boy. Has to take this thing apart. So is it worth rebuilding? Or a question is still on the table. All right. If you're taking this pump apart, I just strongly suggest you just finish taking the whole pump apart. I guess if you really wanted to, you could slap a new set of seals on the water piston as long as it's still in good shape and throw it right back into action. By all means, I guess if that's what you want to do, I'm not going to say that you can't, but I don't know why you would stop there. I would just go ahead and finish rebuilding this thing. It's a few more hours, but here we go again. Is it worth it? Is it not? There's a set screw. Okay, we just have I don't remember the thread count of it. It's a smaller set screw. 5/16, I think, set screw. That's what's, if you guys have never been in here, that's what's, I'll pick the piston up. That's what's in between the piston and the center shaft. So you're going to have to remove the set screw, and then you get to use the next special tool. It's just basically a piece of flat stock with two knobs on it, and that's what locates into the piston. Well, like I said, when I turn this thing around, you guys will see the set screw. You'll see these holes. Go ahead and locate that into the piston. This is where you get to use the mother hammer. Okay, no, like a real hammer. So you're going to probably want to use a real hammer and give it quite a few whacks. You're trying to jar the piston loose of the center shaft, so you're going to have to hit it pretty good. I don't suggest the two-person technique here because that's holding the stake while the other person drives it in the ground. That's me. I know not to do that. So we break it loose. We take the piston off. And I'm going to take one time. I'm going to pause for a commercial break here. So we've loosened this pin. When we get to doing that there, you may actually have to put the set screw back in this side, so that you can break that side loose. You're going to want to hold this piston. Kind of happens to get holes right here. You might have to make another one of these or figure out another way to hold it. 2 screwdrivers, and another person to hold this end while you break that end loose, whatever you got to do. So there's my commercial brake. You may have to put this side somewhat back together to hold it so you can get that piston off. Okay, I've said it, now we can move on. We're going to unscrew our piston from the shaft. Quite a few threads on here. If somehow the threads get galled up, this process becomes absolutely miserable. Those threads are not fun to try to repair or fix, rejuvenate, restore, whatever other words we can come up with. There is a smooth section of the piston. That smooth section goes over this O-ring that's right here on the center shaft. We turn our piston around. There we go. Yeah, there. You guys can kind of, you can see the holes. Here, oh boy. All right. There, that was a lot easier. There's your holes that your tool goes in, and then you can see the set screws in between in the threads there. That's what locked this piston onto the shaft. Putting my flashlight in my pocket right next to my rag that I lost yesterday. All right. You can do these seals right on while it's still on the shaft. If you wanted to do it that way, by all means do it that way. That shaft and the pump, all that weight is holding this still. If you don't, if you're replacing it, obviously you're not going to put it on first and then do this. So what we always did is we got a clamp and we clamp it down to the table. So I clamped it to the table, it can't move. I grab myself screwdriver, I jam my screwdriver in here, and I pry my seal out away from the piston, and then I get a pair of either side cuts or handy cuts. There's Craftsman with the razor blade on them, those types of things. And I just get in here and I just cut that seal, cut the seal, throw it away. You're not going to reuse it anyways. That would be pointless to reuse the seal. When it goes time to put it on. So if I determine that my piston is in good shape and I'm going to replace them, this is the seal. Okay, you can see that scraper edge right there. You can see the O-ring. Make sure you put your O-ring towards the pressure, right? O-ring towards pressure, O-ring towards pressure. This seal is actually pretty, I don't want to say flimsy, it's flexible, okay? Like I can deform it and I can move it, right? It moves. So when it goes time to put it on, it's just like doing any sort of a tire. I like to pick on bike inner tubes and bike tires because most of us have done that. Not everybody's done a car tire, so truck tire, any sort of tire onto a rim. So you put it on and then you would just work it around. I'm telling you, if you guys don't put any sort of lube on here, you're going to destroy something, okay? So my magic secret. Okay, it's not magic at all. Brands don't matter. I don't care about brands. Grease and some sort of penetrating oil. You mix these two together. This is the slipperiest surface known to mankind, or close to it. You get what I mean. Gonna put some grease on here. These seals are, what is that? Oh, can't think. The rubber that's okay to use with oil. All of a sudden, brain.
Nitrile.
Nitron, yeah,
Nitrile.
in there. Something like that. There you go. I'm gonna go with that. I can't. It's just not there. Lube it up, get it all nice and slick, and it basically will work itself on. If you can't get it with your hands, use a pair of pair of screwdrivers, couple screwdrivers, and just pry it on. So you're going to use one to hold it, and then you just pry and work it around. The only reason it's clamped to the bench is because I'm not chasing this thing all over the bench, right? So that's why you can do it on the shaft if you so chose, but you're not going to get that O-ring replaced if you don't take it off. If you don't take the piston off, then you're never going to get the seals that are on the inside of the center block out either. So that's why I just show it to you guys like this, but there's always somebody that gives me the question. So I'm trying to shoot you guys down before you fire it off at me. So, all right. This piston is back in action. All right. We determined it was still in good shape. We put new seals on it. It's ready to go back on when we get to that point. There is a retaining ring. Here's your, well, let me hold one up at a time. Here's your retaining ring. It's, well, currently it's a piece of aluminum. If you have a really, really old pump like this one, it actually has a piece of steel that looks very similar to this. It's got 4 holes. It's a stainless steel bolt, 1/4-inch stainless steel bolt. All right, 1/4-inch. It's got a lock washer. It'll have blue Loctite on the threads. Everybody asks me, it's my favorite question, what's the torque spec of that? And I always tell them, it's a 1/4-inch bolt. 12, 15 inch pounds, maybe. I don't go crazy. You have a lock washer and you put a little blue Loctite on here, this bolt is not going to come out. Okay. Here's your seal. So just a miniature version of the seal that's on the piston. Okay. O-ring towards the pressure, and then the other piston, the other side on the oil faces the other direction. If you compromise the seal on one side, that's how the pressure is going to get across. The other piston, the other seal on the other side is just going to let whatever pressure go right on by. Okay, so you're either going to mix or you're going to leak on the ground. So that's why we are not plugging the weep hole. If you plug the weep hole, you make pressure. Now you mix. If you let it leak on the ground, you know what you have to fix. Weep hole. All right. There's your retainer. Okay. I'm not going to take it out, so I'm just going to show you guys like how it goes on here. So, fits on there pretty tight, right? Just slides all the way into the center block. It slides off the center block. 4 bolts in there. I'm going to just, since we're talking about this, I'm going to touch on it right now. We have had this discussion both directions. I've actually tried it in here both ways. Do you tighten up those 1/4-inch bolts when you're putting this thing back together before the shaft goes through it or after? I've done it both ways. It works both ways. However, my personal preference is to tighten the bolts when I put this in, because I will forget about them. That's me. Okay. Some people claim that when you push this in and it compresses up against the seal, that it actually shrinks to the shaft, which I'm not denying that they're right. I'm just saying that when you put this guard, when you put it back together and you use the guide, it goes right through it because you put the slippery stuff on here. Okay. It's got enough snot on here. It'll just slide right on through the middle. You've polished the shaft up real nice and it slides right through. That's me. Okay. I'm going to set this off to the side. All right. We are now ready to take the oil side apart. Okay. Now we're going to move on to the oil side. We're just going to take this pump completely apart and work on the oil end. All right. This is another commercial break. There is oil on both sides of that piston. If you guys are paying attention to where the oil ports are, you have one on top of this oil end block and you have one on the side of your center block. Your oil level is going to be up to the bottom of that port over there. I don't care how you flip this thing around. We've had them delivered in the back of a pickup, and I saw the witness marks in the back of that pickup that rotor pump rolled around while they were driving it to us. Apparently, it was a race to get there. I don't know why it happened like that, but it did. When we took that pump apart, there was still oil on that side of the piston. As soon as you break the oil barrel loose, this side empties its contents onto the table. As soon as you get the barrel loose of the center block, its contents go onto the table. If you are not prepared for this, this can send you into panic mode because you now have a couple gallons of oil spreading across the table, onto the floor, who knows where else. There's your commercial break. Be ready to contain this oil. We had a table very similar to more of that one over there. It had a trough around the outside, and we would just use a squeegee and just squeegee the oil off the table into that trough, and it ran downhill to the other end, and then there was a bucket that caught all the oil. We also had holes drilled in the table. They were strategic for other things we were doing, and we just put a big gigantic drip pan underneath, and then we would just let the oil drip down through, and we just kept the table as clean as we possibly could and just let the oil go through the table and then off the sides. So we just squeegee all the mess off to the sides. That's what we did. We've heard stories, other people, they just put a bunch of oil dry around the table and just let it run. Whatever. That's your call. That's your mess to clean up. Okay. Truss rods are already gone. Oil barrel and oil end block are still attached. This is where a hammer comes in handy, a little bit of luck, and you give it some wax, and hopefully you can remove your oil end block from your oil barrel. Okay. Usually you just got to break it loose and everything comes apart. Linear sensor is inside here. So you guys can see this. If this center block drops to the table, my oil end block is sitting up higher, okay? It's literally the difference of this 1/4 inch plate that's underneath my center block here. So if I let my center block crash to the table when all of the stuff comes apart, there is a very good chance I'm either gonna bend my linear sensor or I'm going to crack my magnet that's in my yoke. Not something that we wanna do. So how do we prevent that? Well, I hate to be as sarcastic as I normally am, but really it's pretty simple. We're going to take our linear sensor out first. You guys seen this linear sensor yet? Anybody? We're going to talk about installing it and replacing it here in a minute when we talk about putting the other one back together. This is the yoke I'm about to talk to you guys about that's in the center block, right, or excuse me, the center shaft right there, in that center of that piston. This is the yoke. It threads into the center shaft. There's a magnet. Come on out. There it is. There's your magnet. Okay. There's a circlip or a circle clip that retains this magnet into this yoke. You can see the cut lines on there. That's the proper yoke for the magnet. The magnet will set inside go in there. It'll set inside the yoke. There's your magnet. And then your linear sensor is attached to your oil end block. And as your center shaft moves back and forth, that magnet lines up with a whole bunch of, is it diodes, Jerry? Is that what we determined they were, or are they microprocessors?
I don't think they're diodes.
Like they're like little tiny square computer chips. I would call it a microprocessor, right? Because I don't really have a better word for it.
Yeah.
And basically it grounds it out. Okay. So it's identifying based on resistance, the voltage changes from one end to the other. So we know exactly where this yoke is on this linear sensor. So if this end is fixed to the end block, we know where it is. Okay. That's
So
how that works.
So they got rid of the compensator block.
Yeah. Yep. The proximity sensor and that entire thing is gone. This is all there is now. There's an O-ring right here. So when you guys get to replace this sensor, guess what the oil is going to do? That's right there, right onto the ground. So make sure you have a drip pan. Sometimes this is one of the reasons that I like to have the truck sitting here is because usually there's a fender right about here. Trying to get this linear sensor out with that fender in the way. Okay, the next truck I bring in, there'll be nothing there. And this sensor can come out and do a dance and flip around and go right back in and not touch anything. So, little mental note for you guys. There can be a challenge just getting this sensor out of the end block and not running into stuff. Fenders, tires, toolbox. Gosh only knows what else they'll shove on the side of a frame rail. So that's just a mental note. The other thing is if you can try to position the oil piston closer to the oil end block, because I don't know about you guys, but if I'm trying to go through the end block here and my piston is way down here in the dark inside somewhere where I can't see, this is really hard to get that. I can't even do it on a camera, so let alone inside there, okay? Mental note that one. Try to shift your piston all the way to the oil end block. If your sensor's not working, you can't see it, how else can you know? A little bit of water in your water end, and when it comes out the drain for your center block, you know the piston for the water is all the way over, which pushes the oil barrel. Oh, that's how we can do that. position it all the way over so it makes replacing this as easy as possible. Okay, good to know. All right, our sensor's out of the way. I'm gonna just push this yoke back in so you guys can see that. Now I want to take my oil block off, and then my piston will then probably crash down to the table because my pump's gonna fall. That's what's gonna happen then. Oil end's out of the way. Got to put the barrel puller back on. Okay, so now we have it on our piston. We crank the handle, the pusher pushes up against the piston, pulls the barrel off, barrel puller. It will be okay to run it up against the yoke if you so choose. It will be fine. It's a big flat surface. However, this is the 1.5-inch socket. Okay, everybody has an 1.5-inch socket. You got an extension, got your impact, remove this, get it out of the way. Okay, get it out of the way. Then you can use that barrel puller. It'll go up against the edge of the piston, the end of the center block. It will pull it off. No worry of damaging anything. Okay, we can take all of that stuff off. If you guys have done a plus, just a little heads up, that does not work. This is your yoke assembly for a plus. That's what's screwed into the screwed into the center shaft on the oil end. You have to remove this before your pusher can go up against it. Otherwise, you're going to run into the end of your proximity sensor. It's not going to work. You're going to break something. If you guys have ever tried to get a nut off that has this much stuff sticking through it, that's an extremely deep socket. There is somebody that makes one. If you guys need to know about that, just send us an email or a message or whatever, and we'll get you some of that information. This is for a plus, so I'm not going to talk about it, but I do want to let you know the yoke is very similar, but there's a proximity sensor in here. So you need an extremely deep socket. If you are smart, you might be able to figure out how to make a regular socket that much longer. A piece of pipe maybe and a socket cut in half. Okay. That's all I'm going to say about that because apparently there's some liability issues. All right. We're all mechanics, right? Adapt and overcome. Yeah, that's what I'm talking about. All right. How do we get this center shaft out of our center block? We have a simple clevis and an old yoke. Could you just drill out your yoke? I guess you could. I don't recommend that. These yokes are pretty cheap. So that's a tool is an old yoke or a new yoke that's been modified to a tool. That'll be your cheapest tool you have for this entire process. All right, get it there. Now we have some way to pick it up, okay? You can use a cherry picker, a crane. I guess if you have Helgi in your shop that can pick this up, then he grabs onto that and rips it out of there, whatever. This is a thread protector. So it's going to go over those threads on the end of the center shaft. It will also work as a guide for the retainers in the center block and the seals in that center block. It will guide the center shaft through when we're installing it. So it protects the threads and it's a guide. Cool? All right. You can't mix them up. They only go on one end. It's a 1/2-inch bolt in this end of the center shaft. Not really a whole lot to this. So it's protection and it's a guide. There we go. All right. If this works, yeah, there we go. Helgi could pull this out of here. A cherry picker could pick this up. A crane could pick this up. And you just pick it up and you're going to stand it up upright, and this center block's going to hold on to it most of the time. All it takes is really a whack from a dead blow. Just strike it on the end, which will be positioned this way. So just strike the center block. The center block will then slide down the shaft, slam into the table, and then usually you can just do that a couple times and remove the center shaft from the center block. Now you have this pump completely tore apart. The last and final thing was to take the oil piston off of the shaft, and that's just to get to that O-ring. That's all that's left in there. The seal kit, it comes with piston seals, O-rings for the shaft. It comes for O-rings for the center block, both sides. Oh, that's another kind of note you guys might find interesting. On the water end, so the water end, you can see the lip on the edge of the center block. So this locates inside the water barrel. The oil barrel actually goes inside the end block and inside the center block. Okay, so they're exactly opposite how they locate or how they lock together. Okay, so that's why when we push them, when we compress everything together, it straightens out. That's because there's these grooves on this side, and then it goes inside the chamber on the water side. Cool. Anybody got any thoughts, questions, concerns? Because otherwise we're going to move over here where we put it together. Nope. All right. A lot of this, I'm just going to point back over here. Most of this is reverse. So if I could literally just hit reverse on your brains right now, that's how this thing goes together. There's really just a couple simple tools over here that I need to show you guys. And then you will know everything I know. That's scary, by the way, in case you guys didn't know. All right. Once I walk away, I don't want to come back over to this camera. So, okay. All right. You guys, first and foremost, first thing is we put those center seals in, put those retainers in, tighten them, don't tighten them. Doesn't matter to me. Just make sure those bolts have Loctite, a lock washer, and are snug, tight when you put them in. I don't care which direction you do it. Make sure that it's lubed up. You got a shaft, clean, polish the shaft. Use the insertion tool. It slides right in. It goes right on. This hole that's in this table, you can see it's just white. Yeah, there you go. That's the hole through the table. This is the old assembly table. They would set the center block on its end, and they would just drop the shaft through there. Usually you got to wiggle it, the weight of it, kind of tap it with the rubber leather mallet, and it'll drop right through. Usually they put it about the center. We'll come back to that in a second. Kind of like this pump is set up where the pistons are about centered on either side. You drop the center shaft through, then they would pick the entire thing back up, lay it on its side, and then slide it onto the table, and it would end up in this position. Go ahead and put your O-rings on your center shaft. It's a great time to do it. They would then coat the threads of the center shaft with like a white lithium grease, and that just helps the threads not gall up. I'm telling you, that is a horrible day when that happens. I've seen it happen once. It was a nightmare trying to hold the shaft, hold the piston, get the old piston off, fix the thread. It was a nightmare. So do everything you can to prevent that one. That one was definitely frustrating. Screw our pistons on. You can do both of them at one time. You can work on one end at a time, whichever. I'm going to say just go ahead and put them on. It's probably the best thing you're going to do. And then you're going to position your piston in an orientation righty-tighty, lefty-loosey, right? So if we're going to tighten it, we're going to slam it that way. You can see our tool has been beat on with a hammer. You're going to want to get it snug with your hands. This time with brand new seals on here, it's actually pretty snug inside there. You saw how I pulled that center shaft. Once that's through there, you're probably not going to pull it. I can't move this one, so it's probably not going to happen. So you get your tool on here, you get it into a good position, and you take a real hammer and you drive this bad boy down to tighten it up. 2, 3 really good whacks, make solid contact, solid tightening. It will spin the entire shaft. You are tightening up that piston to that shaft. You will drill a new hole for your set screw. Do not reuse the old one. Even though it looks like it'll work, don't do it. A couple of reasons. I won't put a number on it. One is that we will know that it's been rebuilt. That piston has come back off and gone back on. We know it's been rebuilt. 2, it will not line up. You think it does, but it backs it off just enough. Now the only thing that's holding that is hope and your set screw. There's nothing tight on there. It's going to move a little bit. Just don't do it. Not a good idea. Not recommended by anybody at this place who's ever done these, okay? Drill a new hole, put a new set screw in. The other bit of information I want to express to you guys on that, where's my set screw go, is when we drill and tap that, we actually drill it a lot deeper than what it goes. Reason being is we want that set screw set inside the surface of the piston. And then when that last few threads you can see from the outside, we get a punch in here and we ding the thread. So not only is there blue Loctite on the threads, there's also a ding on the threads that you're inside of. So that if this somehow were to come loose, that damaged thread will not allow this set screw to come out. There is no way that this set screw's coming out. Okay, that's the whole idea. Put that bad boy in there. Do not let it come back out. All right, got new piston, rebuilt piston, new seals, whatever. Put our pistons on, tighten them, put our new set screw in, drill a new hole. Our center shaft will have a center block around it. We'll have new pistons that are tightened on either end. And then we get to install the oil barrels. I have a pusher bolted to the table, and I have a stop at this end. I also have a highly tuned, ultra detailed piece of 2x4. I'm pretty sure it came out of my bathroom wall when I remodeled it however many years ago. That's a custom piece. If I write Vactor on that, that thing is very valuable. All right. This is $99. Yes. Heck yes. All right. Here is our seal compressor. Anybody ever used a ring compressor? That's the exact same idea. We got these lips on these brand new seals, right? The lip on one side and then the lip goes the other way. Our pressure is on either side of our piston. This seal compressor. So what I do is I like to put it on here and I'm going to just point to this side because you can see it a lot easier. I leave a little bit of the piston exposed, but I have the seal completely covered by the seal compressor. Okay. So then all we do is just going to tighten this up. I'm not actually going to go through this the entire way because then I just have to undo it for the next class. If you guys were here, we would do this, but since we're not, I get to cheat. All right. I have a little bit of my piston exposed. What that allows me to do is that allows me to get my barrel up onto the edge of that piston. My seal compressor is completely tightened, which then compresses my seal all the way down below the surface of the piston, which then allows my barrel to slide on it. Once again, I've used my grease and penetrating oil of whatever brand or source that your heart desires. Pry bar. I have a pry bar because I like my fingertips. What I do is I just grab my barrel and I just slide it on. Now everything is right in line. My center block is sitting flat on the table. My pusher is bolted to the table, and I'm just going to push it on. I'm going to stop right here because this is about the point where the barrel is starting to contact the seal compressor. If I keep pushing, I'm just going to end up pushing my entire assembly up against this block. Until I put resistance up against this piston, it's just going to start pushing it across the table. That's why there's a stop. That's why there's that piece of 2x4. And all of that is to try to keep the pistons about centered with the center block. Okay, if I don't stop it, if I just let my piston go slam into here, that's fine. That works great. Now I have to rewind this entire pusher all the way out because now I'm going to have, when I spin this around, I'm going to have a barrel on that end, which obviously makes it longer, right? Okay, everybody's cool with understanding that. All right. Before I go any further, I know we talked about the color of the stripes. One would think black means oil and blue means water. That is not it at all. And you guys aren't here, and we've tried this so many times, I've given up on it now. But I can tell you that there's a W right here for the water end, high pressure on my center block. That's the water side. Here's my water block. Okay, we've identified the pump. My oil side, my oil piston. I got my oil port on the side. This block has an O stamped into it. I could also use my file, see if it skates. I can hear the sound. Okay. No, we're getting close on time, 51. Okay. So I've pushed this barrel all the way on the piston. I'm just going to push. I have my stop. I pushed it on. I kept my piston centered on the shaft. My barrel's on. I'm going to spin my pump completely around. I'm going to do the exact same thing I just did on this end. I'm going to get my barrel positioned onto the edge of my piston with my seal compressor. I'm going to get my pusher up against this end of the barrel. Now I'm going to take my highly calibrated Vactor 2x4, and I'm actually going to put it inside the barrel, but still up against the piston. And now my barrel and my stop will end up touching, and then my piston will be inside, and my 2x4 will be inside up against my piston, keeping my piston from getting shoved to one end. What that does is that keeps our piston about in the middle. Remember I was telling you about trying to hit the hole in the dark? That's exactly what we're going for. The other reason is if you put all of this high pressure manifold and then you put the D8 valve and all that manifold on this end, you have it fairly well balanced. If your piston is shoved to one side or the other, the pump is no longer balanced. You try to pick it up in the middle, it's going to want to fall to one side. I actually saw one of these rotor pumps slide off the forks when it was picked up off the table because they had their forks right together and they were underneath the center block. And when they picked it up, the whole pump started sliding. And you guys know when it's this high in the air, there's no stopping that. You can't lower the forks fast enough to keep that pump from slamming into the ground. So I've seen it happen. I've seen the weight be too much to one side. They weren't centered. A lot of things were on the operator of that. I get it. Just set it up so that it's centered. This is the primary reason. There are other safety reasons with the weight on there and stuff like that as well. So mental notes. We have both of our barrels on, okay? Both barrels on either end, okay? Reverse. You guys remember how our oil side has the groove in it? Point you down. See the groove in the oil block? That's what our barrel goes inside. On our water block, it actually goes inside. You can see on the center block here, it goes inside of our barrel. There's an O-ring here, there's an O-ring here, there's an O-ring here, and there's an O-ring in the oil end block. This is where you're going to need to put it up on the shim, okay? You need to get your center block up off the table because your blocks to your shafts, your barrels, all of that, the center shaft, the center barrel needs to be up off the table to put your blocks on the barrel without having to pick it all up, okay? So you have to pick the barrel up. A lot of times, what you can do is you can use these plates. These plates happen to work out to be about a 1/4 inch thick, maybe closer to 3/8. You can use these as a shim as well and get that center block up off the table. Once you get your end barrels on, you put your truss rods through. Okay, put your truss rods through, screw the nuts on. This is a note for those of you that are OCD like me. I'm extremely, crazy, kooky, whatever. I got a thing about making sure that my threads are the even on either end. It just looks better, and I want it to look the best it possibly can because let's face it, I'm going to rattle can this thing when I'm done to make it look as good as I can. So if I remember the 4 inches of thread on this side and the 2.5 inches on this side, if you have it all lopsided, maybe over here you have all sorts of different lengths, or you have just completely messed up, and somebody sees your rotor pump all rebuilt, and that's what they see. Like, what do they think the work on the inside of the pump is like? Okay, that's me. I'm crazy like that. So I'm going to make sure that I put my nuts on. I'm going to start at the water end, put my truss rods through. I'm going to put my threads at an equal distance most of the way on my water side. I'm going to come down here to my oil side. I'm going to put my truss rods through. I know that I have this in here as a shim. I get that. We had extras. That's how we discovered it. Once everything is put together and you have 2 truss rods tight, you can then take that out from underneath there. It's not going to fall. Once the barrels are on here and it's actually pushed together, it usually holds itself pretty good. I wouldn't try to move it like that, but okay, enough. Put your truss rods through, line up your threads, tighten up your nuts by hand. You can use the 1/2 inch impact if you want. I'm telling you, you're wasting your time because when you put the torque multiplier on here, the torque multiplier 4-to-1 is what this one is. So I need to go, 300 foot-pounds with a torque wrench. Not many of them do that, so this one's actually kind of underrated for 1200, but okay. If you use your small half-inch impacts, you're going to tighten them up and you're going to run your torque wrench about 700 times each nut. It's absolutely ridiculous. I get the big boy back out and I tighten it until that big impact can't tighten it anymore, and then I put the torque multiplier on it. You might need a friend to hold the wrench on the other side just so that it doesn't mess up your thread counts and make it look all goofy. Here's my last bit of warning. You are going to hold this rotor pump to the table. It will flip it over as soon as you put this torque multiplier on it. I've never seen it happen, but I've watched I've watched plates, I've watched angle iron, I've watched threaded rod absolutely scream for mercy because of what was happening with this the torque multiplier. 1200 foot-pounds is no joke, okay? If I can flip this over with this pry bar into the truss rods, I can roll this whole thing over. I guarantee you 1200 foot-pounds with that torque multiplier, I'm going to flip this thing over. So definitely have to mount this to something, okay? You're going to do each one of them. Remember, the crisscross pattern is always a good rule of thumb. Any seasoned mechanic will agree to that. You're trying to get this pump to go straight together. The last thing you want to do is tighten up the top right corner and then go to the bottom right corner and then actually pull one of your end blocks out away from the barrel. Not a good thing. Just tighten it up, crisscross, both ends, just crisscross. Once you got it tight, hammer down with the big impact, hit it with the torque multiplier, 1200 foot-pounds. Your pump is now all put back together. Put all your manifolds back on, your hydraulics back on, put it back on the truck, connect your water supply, hydraulics, plumbing, everything, and then go run this thing. Make sure it will actually perform to what you need it to perform. You may need to adjust a few things. Most likely, you're going to need to adjust your bared relief. I don't ever remember actually having to go in and adjust my main relief or my compensators after this. But mental note, make sure that your hydraulic adjustments are on spot. Make sure that your bared relief is on spot. You want your gallons per minute that your truck is rated for at your PSI. Remember, I said at your PSI. Okay? It's real easy to get gallons without PSI. I guess you could get your PSI without your gallons. Either direction, you could overachieve, underachieve. If you have issues with that, contact us or your dealer, and we'll hook you guys up with further troubleshooting at that scenario. That changes the ball game completely. All right, there's your pump. It came apart. It went back together. Hopefully that makes some sense. There is an old document from like 06 that we have. We can send you guys. It's step-by-step instructions. We are working on updating that. It's right just about 11 o'clock. I'm going to stop talking. Jerry can dismiss us. That's it for now. We'll see you guys.
Thanks, Matt.
Quick question before you go.
Sure, I'm still here.
I was just wondering, is the seals all the same both for the oil and the water side?
Yes.
It's the same seal. Okay.
Same seals. I actually have a part number here.
On the piston, right?
Yeah.
Yep. Yeah, all 4 piston seals are the same. The center block, the smaller ones, those pistons are exactly the same. Yep, it won't matter.
Okay, that's all I was wondering. Okay, thanks.
Perfect.
Yeah, the seal kit. It's you can get the seal kit. It has all the seals for to rebuild that pump. But 37495A-30. Then that'll give you if you're going to rebuild both sides, you'll have to get 2 of those kits. So that seal kit is just for one side. So, all right. Any other questions, guys? All right. We'll break for lunch. We'll see you guys in 2 hours. And we'll next up is nozzles.
One question.
Yep.
Yeah, how much is the clearance between the piston and the liner or the barrel, whatever they call it? The clearance.
Oh man.
He didn't measure it. He didn't measure it a bit. I mean, when we're supposed to be reuse the piston or just to put the seals, but we have to use the barrel, the old barrel, and the old piston. We're supposed to be measuring the clearance, right?
I've never heard of a value for that clearance. Have you, Matt?
No. Yeah, you're
That's
not gonna
because,
measure. You're not gonna measure a piston to cylinder wall clearance. Let me hit my button here.
Oh, let me exit mine.
I
thought
I
that's
think
gonna
it
be.
kicks you out. There we go. All right, so this is about the best I can show you.
There's the
So you
clearance.
see this lip right here?
The seal, but you remember the piston is running all the
that
time.
seal takes up that space. That's
Yep,
what pushes
the
the
seal.
piston back and forth.
The seal is what does it. Just like piston rings on anything else, any sort of seal or rings, the seal is doing all the sealing. That piston better never touch that barrel. So there's a fairly significant gap between there. When when this lip is gone, you're going to notice a performance loss of the pump. The pump will not gallons or pressure, and we're going to talk about that next. The seals will be the cause of that.
All right, thanks.
Or a couple other things, but yeah. They wear flat. So when you rub your hand across it, you don't feel this lip right here. When it's worn out, you take this off and this thing's about smooth. The lip is completely gone. If you guys were here and you touched this one, I mean, there's just a tiny lip. I don't even know, 15 thousandths maybe of a lip. And the brand new seal on the other piston over here, I'll move you over here to look at this one. Of course, there's a black background. So this lip is probably in the neighborhood of like 30 thousandths. There's a significant lip here compared to the other one.
Yeah, I thought that's because that's I mean, it's running all the time, and with with the high pressure and all this kind of stuff, so it doesn't make it like I run out the piston and the liner.
Oh yeah, the piston is not contacting. Plus, it's a rubber seal, so everything's moving really slow, and the surfaces are extremely smooth for the barrels. So that's why we can run the pump dry, and it's not going. There shouldn't be any wear. I guess at some point, the barrel could wear out. If you rebuilt it, I don't know how many times you had thousands and thousands and thousands of hours. At some point, you might have an egg shape on your barrel, but you're going to see that in your piston as well. You're going to pull it apart and you're going to be like, hey, my piston seal is still really good shape. Why can't I get my pressure? That could be something to do with this, but that's going to be one of those freak things. That's not a normal rebuild. You're going to have so many hours on that truck. It's going to be
a long time.
You're getting into the 1,000,000-mile Honda at that point where you got crazy stuff going on.
Yeah.
That's not the normal. No.
Yeah. All right.
I mean,
All right,
I understand
thank you.
where you're coming from. Yep.
All right.
All right.
Thanks.
I'll hit my button.
All right. Any other questions, guys? If not, we'll break for lunch. We'll see you guys all in 2 hours, an hour and 55 minutes.
Oh, man.
All right. Thanks, guys. We'll see you later.
Yeah, after chow time.